Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over the remaining problems of the Limits Interactive Multiple Choice Practice Test. All right, so this is part 3 of our 3-part series. Let's take a look at question number 10. So we are going to evaluate the limit as x approaches 0 of this complex fraction here. Now what you'll notice is if you evaluate this limit by direct substitution just as it is, you will have 1/2 minus 1/2 in the denominator, which would give you an undefined expression. Okay, so let's go ahead and simplify this complex fraction. I'll just multiply the numerator and the denominator by the LCD of the denominator, which is 2 plus x times 2. Okay, so multiply the numerator and the denominator by 2 plus x times 2. That is the LCD of the denominator of the denominators of this expression right here. Okay, so top and bottom 2 plus x times 2. Now if we simplify the numerator, we're going to have x times 2 plus x times 2, so we can put the 2 up front. And then in the denominator, if we distribute 2 plus x times 2, we are going to have, so when you distribute this 2 terms to this term, the 2 plus x cancels out, so you have 2 minus, and then when you distribute to this fraction, the 2's cancel out, you have 2 plus x. Okay? Now if you simplify further, you're going to have 2x times 2 plus x divided by, these two add up to 0, by x. Okay? And now you can proceed to evaluate your limit, but just a real quick correction here. When you multiply, you don't want to forget to change your sign here because of this minus that we have here, it needs to be distributed to the 2 plus x, so we have 2 minus x. Okay, so there's going to be a negative right here, so we have to be careful with that. Okay, so now we can divide. If we divide, we can divide the x's out. X goes here 1, x goes here once. So we're left with the limit as x approaches 0 of 2, well, we can bring them negative up, negative 2 times 2 plus x, and then just substitute here without any problems. Negative 2 times 2 plus 0, which is negative 4. So our answer is option letter B. All right, let's take a look at problem number 11. So this limit is a directional limit that we are looking at here. We're approaching negative 3 from the right. All right, so with this one, we can go ahead and factor the denominator. If you notice, the denominator can be factored. So we have x plus 1 in the numerator, and in the denominator, this is a perfect square trinomial. If you factor this, you're going to have x plus 3 quantity square. All right, so if we take the limit as x approaches negative 3 from the right of x plus 1 over x plus 3 to the second power, we're going to find this by direct substitution. Okay, so we're going to have negative 3 from the right plus 1 on top divided by negative 3 from the right plus 3 square on the bottom. Okay, in the numerator, we're going to have negative 2 from the right. We subtract these 2 and preserve the directionality of the 3, divided by, in the denominator, if you subtract these 2, negative 3 from the left plus 3, you're going to end up with negative 0 from the right. And then you're going to go ahead and square that. If you square that, you're going to end up with negative 2 from the right. And if you square a negative number, you're going to end up with a positive number. So it's going to be a very small positive number. Okay, so what happens when you divide a number by an extremely small positive number? You're going to end up with negative 2 times infinity, which is just negative infinity. All right, so the answer is option letter E. Okay, let's go ahead and take a look at number 12. So we can just make our direct substitution here. We'll have negative 1 from the right, quantity square, over 1 from the right minus 1. Okay? Now, if we go ahead and simplify that, we're going to have negative 1 from the right square, still going to give us 1 from the right, divided by, and then downstairs here, 0 from the right. Now, just as we did in number 11, if you are dividing a constant by an extremely small positive number, you're going to end up with infinity. Okay, but we have a negative here, so this can be viewed as 1 from the right times infinity, which is just negative infinity. So your answer here is going to be option letter C. Now let's go ahead and take a look at problem number 13. We're approaching negative 1 from the left. So we can write the numerator as x plus 2. And then we can go ahead and factor factor the denominator. So we'll factor the denominator. This is a perfect square trinomial also. This is x plus 1 quantity square. If you don't remember how to factor, you can use the x game. AC is 1, B is 2. Two numbers that multiply to give you the top and add you to give you the bottom, 1 and 1. So this is going to be x plus 1 times x plus 1. You learned this in Algebra 1, which is x plus 1 quantity square. Okay? Alright, so let's go ahead and take the limit as x approaches negative 1 from the left. So we're going to have negative 1 from the left plus 2 divided by negative 1 from the left plus 1 quantity square. Okay? Alright, so if we simplify this, we're going to have 1 from the left in the numerator divided by negative 1 from the left plus 1 is going to be 0 from the left square. So you can put a negative here, but it doesn't really matter since 0 has no orientation. All that matters for 0 mainly is the direction that you're coming from. Okay, so here we're coming from the left. When you square that, you're going to have 1 from the left divided by. Now, what happens when you square an infinitely large negative number? So, for instance, let's say this is 0, and then if this is 0, and you're approaching 0 from the left-hand side, what kind of number is this? It's something like negative 0.00000, infinite number of zeros, 1, okay? Now, what happens when you square this number? If you square this number, the biggest possible negative number, the sign changes to what? Positive. But it still even gets infinitely smaller. So you have 0.000, infinitely many zeros, 1. Okay? So all that this squaring does is it changes the direction to 0 from the right. Okay? So 1 over 0 from the right is the same thing as 1 times infinity, which is equal to infinity. Alright, so our answer is option letter B. Alright, let's take a look at number 14. So here we're going to have to evaluate this directional limit by direct substitution. So when we substitute negative 1 from the left into x, we're going to have negative 1 from the left square minus 1. Okay? And then when we square this, now what happens when you square negative 1 from the left? You're going to get 1 from the right minus 1. Well, how is that possible? Now think about what this number looks like. If you have a number line, -1 from the left is a number that's really close to -1 from the left-hand side. So -1, if you're approaching this value from the left, an example of such a number is -1.0001. Okay, so -1 from the left can be approximated by -1.00, infinite number of zeros, and then 1. Now what happens when you square this number? What happens when you square this number? You notice that you're going to end up with a positive number that's really close to 1. From what direction? From the right. So this basically becomes 1 from the right. So this squaring changes both the sign and the direction of -1. Alright, so you always want to keep that in mind. Okay, so now if we go ahead and simplify this, we're going to have 2 divided by 0 from the right. This whole thing is infinity, but let me show you the steps. 2 over an infinitely small positive number is the same thing as 1 over infinity. And then 2 times infinity, your final answer is infinity. Option letter B. Okay, let's take a look at question number 15. So this is an infinite limit that we can evaluate by direct substitution also, okay? So if we plug in infinity into the x, we're going to have e to the -2 times infinity plus 2. If we simplify that, we'll have e to the 2 times infinity is infinity plus 2, okay? And then this becomes, using the reciprocal property of exponents, this number here becomes 1 over e to the infinity plus 2. And then e to the 1 over, e to the infinity is infinity, right? Plus 2, and then 1 over infinity is 0 plus 2. Final answer is 2, option letter D. Okay, let's take a look at question number 16. Very similar to what we just did. This limit can be evaluated by direct substitution also. Okay, so we're going to have, if you substitute infinity for the x, we'll have e to the -2 times infinity plus 4, which equals e to the -infinity plus 4, which equals 1 over e to the infinity plus 4. Okay, and then this becomes 1 over e to the infinity is just infinity plus 4. 1 over infinity is 0 plus 4. 0 plus 4 is 4. Your final answer is B.